All right, so hopefully you had an opportunity to talk to the exhibitors, mingle a little bit, imagine how all this comes together, and see the challenge that we have before us, right? How do we unlock all of those opportunities and being smart about it and really ripping apart our bureaucracy to the greatest extent that we can. All right, so this is a unique topic for us. We knew, we had a premise that we could help facilitate this dynamic in the autonomous vehicle industry. As I recall, going back to, Eddie may remember, but it was almost a year and a half ago, and the day that Uber brought 6 autonomous vehicles from Pittsburgh, where they had been having an agreement when they'd been utilizing them, and brought them to San Francisco and said, all right, we're starting our autonomous vehicle program and testing in San Francisco. Later that day, they got a cease and desist from the state. And then the next day, the governor of Arizona tweeted that, hey, we love autonomous vehicles, come on out, right? And then that weekend, those vehicles were on their way to Arizona. And so it really highlighted this collaborative environment where the policy could either be a barrier or be an opportunity. And so it set us on this path of really thinking about autonomous vehicle proving grounds. And so we crafted this vision, right? I keep going back to vision, but we crafted this vision where we'd create an autonomous vehicle proving grounds here at Miramar that would facilitate that dynamic, but not just for us when we in DoD were trying to develop something, but more importantly, from my perspective, that it would be an opportunity to industry. And industry would be able to collaboratively, get beyond the policy barriers in some ways within the state, but on our basis, and we'd be able to ride that for market forecasting. And so you're going to hear a little bit about how we crafted that, how we're utilizing it, and then how it started the dynamic for where we've gone, what you heard from Jay earlier, and what you'll hear more about, and where beyond installations it takes us into the battlefield and for operations. All right, so we've got a great panel to kind of cover these topics on the autonomous vehicle proving ground. So at the time, we were working with the state, California Energy Commission, and we were going to craft autonomous shuttles that were going to run for 4 years here on Miramar. And so I needed to get leadership. So Colonel Dockery, who you heard from earlier, his predecessor, Colonel Woodworth, I needed to show him that I wasn't leading him into the unknown, into the abyss, right? Like, hey, we're going to have autonomous shuttles and you're accepting all the risk. And so we worked with what was formerly the Army TARDEC Vehicle Lab, now Ground Vehicle Systems Center in Detroit, because they had done an autonomous shuttle in Fort Bragg in North Carolina, moving wounded warriors from the barracks to the hospital. And it was taking some of their autonomy that they had worked on previously for operations, putting in a more commercial application. And I said, okay, I need to link to that. I need to take all the lessons learned that they started there and bring that over and show our leadership from the colonel here all the way to the one-star general at MCICOM over to General Colonese and his predecessor up at Marine Corps Installations Command that, look, we can do this and we can do it smartly. And so to do that, we brought in robotic research, who you'll hear from Eddie Modern here, to be our subject matter experts. And so again, building that ecosystem. And then fast forward, whenever press got out that we were working on this shuttle concept with the state, Qualcomm called out of the blue and said, hey, we're right next door. We've been dreaming of being able to do our testing at the time, going six hours away. And so I'm trying to tie these things together. Part of the premise was never about just autonomy on the installation. It was also about unmanned logistics systems. Moving goods, which is in the last 15 years has been a highly risky endeavor for us on the battlefield. Moving resupplies. How can we expedite this understanding and the requirements around moving goods on the battlefield without drivers in an unmanned system? And so Kyle's going to cover some of that for us as well. All right, so with that, we're first going to go to Paul from Qualcomm. And so just how is Qualcomm structuring itself to shape the future, and why is, you know, this relationship with us and the collaborative research and development agreement that we've created with the Navy's help facilitate that.
Well, thank you, Brandon. Yeah, so Qualcomm has actually benefited a lot from very strong collaboration with Miramar. Started with actually drones a while back, and we moved to the cars and then to connectivity. So, you know, Qualcomm's view of the market, the autonomous car market, is one of, you know, several opportunities that we see. Obviously, we have a lot of core expertise in system on chip. So looking at, you know, cost optimized SoCs for autonomous vehicles is a focus for us. But we see all these new features that can be added for, you know, starting with level 3, moving on to level 4, 5, that also includes the infrastructure. And, you know, connectivity is obviously a core competency of Qualcomm, and that's where we have also the connectivity program going on. So we've actually benefited from 2 programs that are somewhat independent today, but will converge. One is the autonomous vehicle platform, and you've seen that out in the parking lot, which is really looking at a whole software stack for autonomous vehicles with a lot of features, and starting at, you know, fairly simple features of precision lane positioning to, you know, traffic jam aided feature, and so on. And then we have the second program, which is called Cellular Vehicle to X. And Vehicle to X is vehicle to vehicle, vehicle to infrastructure, and vehicle to pedestrian. And that's really a big focus on safety, safety of both the vehicle, but also pedestrian with all the high rate of fatalities. So those 2 programs, you know, technology development efforts will converge at some point, but they're very separate, and we've benefited from these 2 project teams here at Miramar out on Rifle Road, running a lot of test and development efforts. And we've had the benefit to bring on, you know, different obstacles to test at some of the lower speeds. As you can imagine, you know, things like, you know, lane cut in, cut out, taking that onto the open roads has a big consideration for safety. So being able to do some of that testing here at Miramar, we've learned a lot. It shaped the integration of, you know, the Qualcomm solution, the validation. And so the Miramar phase of testing is actually very key to the overall development that goes on at Qualcomm. So we're very appreciative of all the work that Lieutenant Colonel Newell has done and Miramar has offered to us.
Thanks, Paul. So, I mean, I want to highlight a couple things that Paul touched on, which is we aren't their market, right? Like the autonomous vehicle market that they're after, the OEMs of shaping the auto industry, that's not focused on defense. You know, we essentially are riding that relationship to better understand what that market looks like. And that's why the big takeaway for us and the big in-kind support through this collaborative research agreement with them is that market forecasting and the design thing. Typically, those are used for intellectual property whenever the government's partnering with industry. But we stripped the IP out of this CRADA, because it wasn't about their intellectual property. It was about better understanding where the market's going, because we are no longer the market we once were in that post-World War II, you know, environment where we stood up all of these DoD labs. And so we have to find new creative ways to better understand where that market's heading. So with that, I wanted to bring in Eddie Modern, who kind of bridges for us both the expertise, but also the commercial market and the defense market with autonomy. Eddie?
I think this is...
It's just on and off. Tap it.
There we go. Looks like I got this thing working. I can do autonomous robots, but apparently I can't operate a microphone. So my story is a little bit different than Paul's. Back then it was Major Newell who contacted me about providing engineering support or an owner's engineering role at Miramar. And what he was looking for was somebody to be able to look at a lot of the technology that exists and make some sense out of it. Kind of, you know, not necessarily dumb it down, but put it in terms that, you know, people that aren't familiar with autonomy can digest and understand. To give you a little bit about why he selected us, we've been doing autonomy since the late 80s. No one has heard of us until very recently, and that's because most of the work was done while our founder was at NIST. And after that, most of it was done when robotic research was started back in 2002 by supporting large defense contractors, your Lockheeds and your GDs of the world. So to give you a perspective of how a lot of this started, we were doing autonomous mobility before GPS, before there was LiDAR. We actually worked on the first LiDAR systems that were available back in the late 80s, early 90s. From there, we went through multiple programs. We've deployed overseas many times. Again, a lot of this in the military space. You name the vehicle, we've probably, in a military space, we've put autonomy on it. There's always going to be a need for these vehicles to operate in installations, whether you're CONUS or whether you're OCONUS, you know, operating around the FOB and even further out. So in order to do that, we had to characterize how these vehicles operate around people, because that's one thing that we hadn't taken into consideration. A lot of our OCONUS deployments, you know, people in the environment weren't necessarily something that we needed to worry about for obvious reasons. But back at the FOB, you have to worry about all your buddies, about all your friendlies. So we took this, this Fort Bragg challenge, or REBO, and what we did was we took a lot of the lessons learned over the years from technologies, especially autonomous mobility, LiDAR processing, vehicle actuation, and came up with a pretty quick, dirty, cheap program that was going to transport wounded warriors from the Wounded Warrior Transition Battalion to the Womack Medical Center. And what we noticed was the ridership went up after we did this. There were a lot of people that were mobility impaired. They didn't have access to actually get to the hospital. One of the biggest issues, a lot of them had TBI and other issues. They were forgetting that they had appointments. So we developed an app, kind of like a on-demand type app that would do all the scheduling with the vehicles, but would also act as a reminder to let them know when they had appointments, where they had to be to get picked up, and so forth. So that started our look into the commercial world. We're like, wow, if we can do this on a military base, you know, maybe we can do this in the outside world. And right as that was happening is when I met Lieutenant Colonel Newell. And he's like, hey, I want to do something similar to what you did at Bragg, but more encompassing. I want to bring a bunch of people in. I want to bring, you know, industry in. I want to bring local government and see if we can't develop a testing ground that facilitates all the technology that you've been working on, but getting it out there to everyone. I don't want to help just the Army. I want to help the Marines. I want to help the Navy. I want all of this to grow so that everyone can benefit from it. In the long run, it's also bringing costs down, because that's one of the big challenges when it comes to autonomous mobility. Because you know, I'm not going to you know, sit here in front of you and tell you that it's cheap. And if people tell you they have a cheap solution that does it all, at this point in time, they're lying to you. But as far as, you know, where we've gone since then, I think Brandon and I have traveled a lot of places, looked at a lot of systems, and what he's done here is nothing short of amazing. The amount of people and industry that he's been able to bring to Miramar and participate in this is, you know, more than anything I've seen in any other place. All the test centers across the U.S. that were stood up with initially with state and federal funding, they're not doing the level of testing that's happening here and the level of testing that will happen here. Another thing that Brandon mentioned was logistics. That's something as a company that we've been working on heavily for the past 5 years. We're also looking at doing some things with local motors in that arena. We basically do the autonomy for the PLS, which is the Army's large logistics platform. That's been moving very well, and we're looking forward with that. But it looks like we may get an opportunity to actually bring this to the Marines here very shortly. I find that rather interesting.
Yeah, so one connector there is that we work with the Office of Secretary of Defense for Operational Energy on this idea of you know, autonomous unmanned logistics systems on the battlefield. And so they actually gave us the funding to bring robotic research on as owner's engineer in this effort. One of the ways that, besides what we did here, is that we actually supported Major Holloway's office a year ago out in 29 Palms when they were looking at unmanned logistics systems. And the Nikola Reckless that you saw outside was getting tested there. And we brought in robotic research to come and evaluate the system as an autonomous platform for an autonomy applique kit, in this mindset of, we know electric, we know drive-by-wire is some of the critical enablers to autonomy. And so we wanted, even though they weren't looking at autonomy or remote control at the time, we wanted to start looking at platforms that would be ready, ripe for that opportunity. And so here I want to turn it over to Major Holloway to talk about unmanned logistics systems for the Marine Corps and what that means on the battlefield.
Thank you, sir. As Lieutenant Colonel Newell alluded to, we both kind of work for two halves of the INL team. He's on the installation side. I work for LP, Logistics Plans, Policies, and Strategic Mobility. General Maxwell underneath Lieutenant General Schroeder is the DC. And our focus is inherently on the operational side. But over the past couple of years, we've been able to kind of leverage each other's efforts to create synergy and reduce redundancies in the INL efforts as a whole. As Eddie alluded to, we've had a relationship with TARDC and their Expedient Leader Follower program, which is what he talked about with the autonomy on the Army PLS trucks. Kind of history of that program is a JCTD, a Joint Capabilities Technology Demonstration that the Marine Corps and the Army went into in 2012. And the Army continued after it expired in 2015 to now be a semi-autonomous expedient leader follower capability on their PLS trucks. The Marine Corps has monitored the program, and hopefully in the near future we're going to be able to get some LVS trucks, which are very similar to the Army's PLS platforms, into the pipeline to get the applique kit of the expedient leader follower and start getting back into the autonomous vehicle program in a way that we were kind of in the previous decade. A couple of other things that Lieutenant Colonel Newell and I have worked on is looking at things that work both on the installations as well as forward deployed. So we already discussed, and I think Jay will talk about the crowdsourcing collab effort that will have a flavor of autonomy when we move forward. But Brandon was integral in assisting with all of the crowdsourcing efforts as well as the digital thread, providing the autonomous vehicle proving ground here as a venue for that continued success. That's one other thing I wanted to discuss. So kind of talk about robotics research a little bit more and the work that they're able to do in both the commercial consumer space as well as the military space is the Marine Corps Warfighting Labs effort, the EMAV, or the Expedient Modular Autonomous Vehicle, which is an S&T platform that the Marine Corps is invested in. We currently have 2. We're going up to 10 vehicles to do experimentation in all realms of support to the MAGTF to include logistics. And the robotics research team is going to provide autonomy, hopefully, for those future platforms. So robotics research has been part of the Marine Corps, autonomy story for as long as we've been looking at autonomy. So I'm glad to see that he's on the panel, and hopefully we'll be able to use the EMAV moving forward on the autonomous vehicle platform.
All right, so we're showing you both sides of this, both the commercial applications and the operational applications. So I want to tie that together a little bit more with what Jay talked about earlier with on Joint Base Meier-Henderson Hall in Northern Virginia. And so I mentioned earlier that we brought in the Army to collaborate with us on that project. And what the Army lab that's involved, ERDEC, is actually doing is they're running shadowing. They're shadowing the operation and the setup of the system as industry leads it, right? So between robotic research's autonomy and locomotors platform and operation and even the infotainment side, I call it, of the platform. And then that has implications back to our other installations and how we craft these requirements and resource to it. The Army has plans at Fort Carson in Colorado Springs, and then we have plans here and other places as well. And so it's integral to how we move forward when it's an emerging technology that we don't fully understand and the operation that we don't understand. So I'm going to tee up Jay to talk more about kind of this dialogue that's continuing forward and how you see it all come together.
For us, looking at these devices, these are a lot of discussion has gone on in the last decade about the Internet of Things, and these are industrial Internet of Things devices, and they have all of the attributes that are currently being discussed, and they have the potential of so many more attributes coming forward quickly. So we have really been inspired by the crowdsourcing efforts that are out there, the work that we've done in CoLab together, to be able to uncover use cases. It's surprising even to me, running a co-creative and digital manufacturing business, how specific the use cases can be. And so we spend a lot of time talking right now about autonomy, but there is actually how productive you can make a user, a Marine, a serviceman in this vehicle, and that has a lot more than just autonomy associated with it. The connectivity that's out there and the use case of the vehicle, when you think about it, I'll use an example at Joint Base Meyer. If you're taking a disabled veteran around and you want them to be able to know where the headstone is of somebody they served with, that has nothing to do with autonomy. That has everything to do with what you're processing on the vehicle. And so to be able to record their stories as you're doing that would be a use case that could really make these vehicles come alive. To be able to point out all of the other headstones of the people that may have served in that same unit and where they might be in Arlington is an example of how you make that veterans' time more valuable and productive in their vehicle. We spend a lot of time now thinking about the fact that it is no longer taking a driver out of a car and putting a car to go someplace without the driver, but rather what else could you do during that time if you're no longer driving? And shared mobility was kicked into high gear with Uber and Lyft. These will be the most valuable IPOs in the history of IPOs this year. But what does that mean? Today, in an Uber and a Lyft, you sit in the back of a vehicle and you drive from one place to the next. But if the vehicles were different, what else could you do? So we see that for bases and stations and civilian uses so much. And Eddie's pointed out, we got to do in business. The third autonomy provider that we've worked with in the process of Ollie was robotic research. And one of the reasons why we wanted to work with robotic research was not just because they provided a very credible autonomous system, but they were willing to work beyond that in what else you need to do in the connected Internet of Things device to be able to make it really useful. And we've only just begun to play in that. I would say that we're at the first of 9 innings, and by the time these vehicles really come into their capability, people are going to see that it is the whole connected ecosystem. And we've seen a bunch of wireless providers here today, and that also is important to note that handling of data and both the secure transmission of data and then the usage of data and then the secure transmission back to the vehicle to make it more productive. The first time I saw a 4K TV installation in the vehicle with live real translate and the ability for it to operate in the full spectrum of 5G, I was blown away by what that would mean for productivity in the vehicle. And so for professional military education, for TDPs, for the ability to be able to give instructions, for safety, for security, for simply enjoyment of your time and those sorts of things, it's going to be an amazing new world for mobility, and that's what we're excited to see.
That's great, Jay. So, you know, one of the most important things that we learned early on about autonomous vehicles is that there's autonomous vehicles and then there's connected vehicles. You know, autonomous vehicles is the brains, the eyes, the sensing is all on board, all the processing's on board. You know, it's like what you see with Tesla today. The real leap forward in capability that really goes beyond my ability cognitively and my eyesight as I drive is the connected vehicle. The connected vehicle communicates to other vehicles, to infrastructure, to the pedestrian and their smartphone walking across the pedestrian walkway. That's where you have this great leap forward. So there's the autonomy side of that technology that's integral to the connectivity, or the connectivity is integral to that. But with that, it comes back to some of the things that Jay talked about, and what we're excited to see at the Joint Base there in Virginia, and the relationship with Amazon Web Services. And so the cloud computing, the cloud services, even potentially some computing on the edge, right? And so when you have that connectivity that really enables both sides of the house, of these new emerging capabilities. And so that's the tee up Kevin to talk to us about what's going on with Verizon, what we're working on here, even at Miramar.
Well, thanks again for the opportunity. You know, we obviously, Verizon doesn't make any kind of autonomous vehicle, but as I've been listening to the general speak, the commander of the base speak, Brandon speak all day today, every pain point and technology that I heard, I could connect to something that will be a use case or application that will be enabled by our next generation 5G network. So for example, autonomous vehicles. If you think about how they work today, they essentially digitize the world by using computer vision, LiDAR technology, 3D LiDAR, and they digitize the world the way you and I process as we are driving, right? There's a pedestrian crossing, yellow light, red light, stop, take a right when nobody's crossing. They essentially have to digitize it and use business rules to essentially emulate what we do as humans. Now, at the moment, all of the processing associated with that digitization of the world occurs on the vehicle simply because you cannot afford latency. In other words, if that processing was to occur in an edge cloud on a 4G network, because of the kind of latency we have in a 4G network, which is about 100 milliseconds, you could have a blind spot for the autonomous vehicle, and it could hit somebody, not because it can't function well, but because the latency didn't allow it to understand somebody was crossing. And so as a result of that, all those technologies run on board autonomous vehicles. As you look on the horizon, we are building data centers close to the edge of the network where these vehicles are going to be located. They're called the multi-edge compute node, or a MEC, 5G MEC. And at that point in time, a lot of the algorithms that are running inside the autonomous vehicle could actually run in the MEC and create not only a control mechanism for the autonomous vehicle, but the ability to do vehicle to infrastructure, vehicle to vehicle, vehicle to traffic signal, vehicle to other things, Internet of Things, connectivity, all via one integrated cloud, which is located at the edge of the network called the MEC. And so, you know, as we look on the horizon, we see ourselves really an integral part of everything that has to do with next generation of technologies, autonomous vehicles being one of them. We think the costs will come down when a lot of these algorithms can run in common operating environments like a MEC, as opposed to every single vehicle. The other thing that we really think will be conducive in the 5G environment is that, case in point, take this space. First of all, I should say, as I listen to various people talk on the stage, I'm like, I've heard that before, and most of the problems that I heard about, last mile mobility, logistical operations that are more autonomous, the ability to use your GCSS and maybe generate a ticket for some kind of a automated logistics operation, what have you, condition-based maintenance. I hear these kinds of problems from cities and mayors all the time, because you guys are essentially like many cities in these bases. You have, you know, all of the similar kind of construct, parking management issues, security issues, lighting issues, and mobility issues. And so we deal, you know, we have Uber talking to us all the time about employing 5G technology in their autonomous vehicles, next generation autonomous vehicles. Ford is a customer of Verizon. Amazon is talking to us because in the world of logistics, what they're contemplating is having these regional depots where robots and UAVs can actually pick up an item that, you know, mother has a sick child, can't go to the store, needs some kind of a fever reducer. You don't want a one-day delivery thing for that. You want a 1 hour delivery. And the robot can pick that from the local regional depot and deliver that to your door. So talking about logistical operations similar to what you guys need in the military construct. Now, we obviously with the 5G network, we can support what Amazon is contemplating it within the depots in the cities around the U.S., CONUS, because we're going to build a robust 5G network. We can't do it in the forward operating base, but it makes your operations here more efficient in terms of supporting the forward operating base. So, you know, as we look on the horizon, no matter what element you're talking about, augmented reality for condition-based maintenance, autonomous vehicles for mobility, logistics operations, Verizon's 5G network is going to be able to support that. As a matter of fact, it's the only way you can do it. The example I was going to cite is that if you looked at this base, we probably can handle about 400, 500, 600 simultaneous call with 4G LTE densification. Now, as you look on the horizon, when you add all of these sensors from autonomous vehicles, intelligent lighting, intelligent videos that want to stream, computer vision algorithms that are monitoring for intersection safety and other kinds of applications, smart parking, the number of sensors and the number of people that want to talk simultaneously is going to be way beyond the capacity of a 4G LTE network. And if you look at the 5G network, our CEO, Hans Vestberg, talks about the currency of 5G network. Obviously, one of them is speed, because 5G is the equivalent of wireless fiber. So the speeds that we deliver on a fiber optic cable, which is around 10 gigabits per second, we can deliver on the 5G network, about 1 to 10 gigabits per second, wirelessly. So it's wireless fiber. But the more important aspect of 5G is that if you looked at a square mile, we could probably connect 1 million devices, whether it's a light or autonomous vehicle or people talking, to that same radio system, whereas you cannot do that. So as we look on the horizon, for these devices to be connected to the network and to talk to the infrastructure and then use the infrastructure to talk to each other, you're going to need the kind of density that only 5G can support. So as we look on the horizon, there is literally no use case or application where we think would be possible entirely without the use of the 5G network.
All right, thank you, Kevin. So I thought we were talking about autonomous vehicles. That was complex enough, right? And then now we just showed you how 5G is going to be critical to it. And it's like, all right. I spent all morning talking about our bureaucracy doesn't change quick enough, right? Well, so this is what we're doing with the collaborative market. We're finalizing right now with Verizon and Naval Information Warfare Center, so I-werx, formerly SPAWAR, Pacific, another CRADA on 5G that would be here at Miramar. And that allows us to collaboratively move forward and deploy it on the base and look for the applications, look for the use cases. We mentioned the connected vehicle. I mentioned earlier digital fortress. Drones, you'll hear more about that later. Again, having that network is critical to understanding where this is going and what we need to unlock the opportunity. And then that ties back to our crowdsourcing challenge that we talked about earlier. And I had Chris Whaler and Dave Ross, who couldn't be here today, but that relationship and looking at how we drive forward telecom as a utility so that we actually are moving at the pace of emerging technology, that's critical. So you bring all that together. I'm going to come back to Kyle here because when we first started looking at autonomous vehicle and making that leap to a connected, right? We heard that 5G and the connectivity you have to other devices and other sensors, is critical to take that next leap. And we've talked about, okay, how are we going to replicate that on the battlefield? Are we gonna have to fly a drone an hour before the vehicle goes out? Or is that too much latency between sensing the environment? Do I have to fly it real time? Am I going to covertly drop sensors on the battlefield that are going to communicate back to this vehicle, right? An area and a location that we've never gone before, or maybe it's retro-traversing an area we've gone before. So any thoughts, Kyle, on how the environment we're creating helps us craft that future?
Yeah, absolutely. And I think it's important to note that the ecosystem that you're setting up here with the autonomous vehicle proving ground is enabling us to leverage dual-use technology. So the installation side is clearly, as it was stated, like a small town or city or community, where a lot of the stuff that you're investigating may not have direct application to an operational environment, but it's it's something that with a couple of tweaks can be operationalized. So I think that maybe Paul and Eddie can weigh in as well about the network, and you as a communicator probably could speak to it better than I could. But the stuff that Qualcomm addressed in regards to being tied in with the infrastructure is not going to be possible when you're in a forward deployed environment. So having a network on the move that's capable of processing all that data real time with localized sensors and isn't relying on a GPS signal or preloaded maps like you have in a legacy Blue Force tracker system is going to be key. So leveraging a 5G network on the move is going to be absolutely necessary for a connected and autonomous vehicle when you start going outside the wire.
So, and it's a great point. Let me just kind of clarify. In a non-permissible environment, in all likelihood, in a forward operating situation where the environment is non-permissible, it would probably be difficult, if I'm talking about the environment SOCOM operate in all likelihood, satellite is going to be the main mode of connectivity. But when you have an actual base, for example, in Iraq or something like that, where there is infrastructure fiber optic capacity, we probably could deploy not only 5G small cell radios, because again, the form factor is very friendly, but we have cell on wheel, which is essentially a mobile switching center base station that can also kind of fulfill a similar function in the world of 5G. So where I said, in the forward operating base with autonomous vehicles and some of that stuff for reconnaissance, for example, it might be more difficult. I'm talking about non-permissible environments where there is a formal base infrastructure fiber optic capability. There is no reason why we couldn't replicate what we do here or there.
So yeah, I'm going to have Paul mention this, because we've turned to Paul as well at Qualcomm because they've helped shape that market as well, right? 5G with their technology. And so how we turn to them and better understand what that market looks like before we take the next steps.
Yeah, I was just going to follow on. I think Verizon is already looking at this in the commercial world as they look at venues and how they support venues where there's high density needs, and even these venues tend to be somewhat temporal. So where they have events and they have to go out and support. So they're I think very well experienced in the deployable networks that can be leveraged going forward. I think it's interesting. Qualcomm, you probably read in the news, Qualcomm likes 5G. I think back to 10 years ago when we were talking about 5G, and we talked about this component called mission critical. And at the time, everyone says, well, we only care about cell phones, and people only care about smartphones. But we really talked about mission critical, and that really grew very fast in terms of, okay, what does that really mean in the space of autonomous vehicles, Internet of Things, connected devices, the medical world of needing a lot of data, needing it fast, and needing it almost real time, and that's where the latency comes in. Drones has come into that space, or robotics in general. So I think 5G is clearly a technology that has evolved very fast. It's evolved much faster than 4G, and the rollouts that Verizon is doing is a testimony to that. So that now all of these different applications, and a lot of them safety critical or mission critical, will now happen much faster as a result of 5G.
So I'm going to turn to. So one of the feedbacks we got from the morning session is that we wanted some time for question and answer. So we're going to do that now. Captain O'Reilly's going to walk around. So we've got about 10 minutes here for you to ask some questions of our panelists and see where it goes. You can have this. Questions?
Yeah, thanks. This one, it's related, and it's something that we don't often talk about it because it's not sexy, and it might be mostly at Kyle and for Kyle and Jay. But when you talk about autonomous vehicles or even the network, a lot of times what we don't talk about is sustainability. And so what does that model look like to sustain these vehicles or sustain that network? And is it a traditional model where you have a weapon system or a network that's out there for 30 years, or is it more of a disposable model that you might use. And Jay, I remember you said something, maybe you coined it, maybe you didn't, but it sticks with me that you did, cradle to cradle. So can you talk about that a little bit?
So the word cradle to cradle is actually a trademarked word, started I think by Bill McDonough, one of the originators of the LEED building certification, and it's a moniker that he uses and his foundation uses in order to be able to describe a full circle ecosystem. If you really read into it, it has a lot of genius that's behind it. And we think about everything from the sustainment on our bases for what the ecological signature is of throwing rounds downrange. We were talking about that outside recently. But also when you think about leaving theater and vehicles that you simply don't want to put on a ship and bring back. And so what are you going to do? You could transition them to a friendly nation. If it's not friendly, then are you just going to leave them on the beach? So these are things that we need to think about, and we do think about. The concept of building a full tail isn't just about servicing vehicles on a base. It's also about what you do with vehicles in an operating environment. And so humanitarian assistance and disaster relief, the last thing you want to do is bring a ton of vehicles in that then pollute the ecosystem themselves. And that becomes even more an issue when we are looking at battery electric vehicles. That doesn't mean the batteries are bad. They happen to be some of the backbone that makes connected and autonomous vehicles work better. But it is still something that we need to think about. So full service mobility as a service goes all the way down to the sustainment level. Just as a note, we print vehicles right now, as I've noted, in 10 hours. There's also material that we use that is compostable, and so it doesn't have the same structure as some of the crash structures that we have, but there's a lot of the vehicle that isn't a crash structure. So to print out of a bioplastic that's reinforced with a bamboo fiber, and then being able to see that just chopped up and put in the ground, that's a really next generation way of looking at the way in which you build a vehicle and is part of the sustainment story.
Just to add to that, I think you might have coined the term who asked the question. It's making obsolescence obsolete. So not just sustainment of autonomous vehicles, but all of our major end items moving forward, leveraging advanced manufacturing as far forward as possible, and then leveraging a digital thread to ensure that we're having iterative maintenance and upgrades of any weapon system or vehicle that we have in the future is key for the future fight.
Good afternoon. Thank you for this wonderful session, actually for a wonderful conference. My name is Eva Lerner-Lamb, Transportation Systems consultant and representing the American Society of Civil Engineers here today. As the Marine Corps is doing this incredible job of trying to advance its operations, its community building really, with the civilian community, trying to catch up to where technology is. I guess my question is, how do we, at the same time as we are customers of the new technologies, how can we hold the technology companies to task for the security of the data that's going to be transmitted back and forth? And a lot of the tech companies, not only of the ones up on the board today, but a lot of the companies that do own a lot of the tech that we're using. ChargePoint is one of them. There are a lot of tech companies that are actually owned by foreign enterprises, in particular China. And that data now belongs a lot to them as well. So scooter information.
So Eva, that's a perfect question. And so I'm actually going to turn to Verizon and Qualcomm with this. And one thing I want to highlight before this is we think of ourselves in this uniform as the authorities of living in a secure environment, right? Because everything about us, you know that it requires that type of protection. And where, in my hypothesis has always been that we've missed the mark in this, is that industry has actually a lot more riding on the cybersecurity and the performance of their system, where dollars and cents drive them, right? Where the losses are immediate, right? The impact is immediate to them being compromised. And so we don't often see that they're actually well advanced of us with our regulations on cybersecurity in this regard. And so I want a chance to have maybe all three of you kind of address this from the industry side. Starting with you, Paul.
Yeah, I'll just add a quick comment. As I mentioned, mission critical was one of the fundamental pillars of 5G. Security was probably a bigger one than that. So when we looked at, okay, what is you need more data, you need more connected things. The underlying fabric of security was very much forefront on 5G, and I think Verizon might want to say more about that.
I don't have too many deep thoughts on this one, just because we're a consumer of the technology that Qualcomm and Verizon provide. But being in the military space, I would like to address quickly a previous comment. The way the systems are designed for the military, we're communication or network agnostic, meaning that we have to build enough intelligence into our platforms that they don't need to be connected. They're connected when they need to be, but that's not, in reality, on the battle space. You can't rely on GPS, you can't rely on comms, even SATCOM you can have issues with. So we have to take the physical security of our systems more important than actually the network, the network side of being secure.
Well, I mean, first of all, bear in mind that Verizon has been providing mission-critical secure networks to the military intelligence agencies for decades. So we're really good at that. But one of the things, I think if you talk to our chief technology officer now and our CEO, who was a former chief technology officer, the thing that keeps us awake at night is not being able to build this 5G network. We are absolutely confident that we can build it. It will have low latencies, under 10 milliseconds, ability to support millions of devices in every square mile, and throughput rate of 1 gigabit to 10 gigabits per second. At the minimum, those are the three key currencies that you get out of it. But the thing we really are concerned about is as the military cities rely on us to have all their lights, their equipment, their vehicles connected to our network and supported by that 5G network, the importance of security becomes even more paramount. Because now if there's a problem, our military is having a problem, our cities are having a problem, and these are operational, mission-critical operational problems that can adversely affect the country. So one of the key things, and this is probably a little less sexy of an issue and doesn't get as much attention, that is being baked into the design of the 5G network is that we could have rolled 5G maybe 4 or 5 years ago, but we first started by defining a software-defined networking layer in all of our core and edge networks, and now we have a secure defined perimeter that's enabled by that software-defined networking that's going to support every 5G connection to a device. And there'll be a X.509 certificate on every sensor that identifies itself to know. So a Qualcomm system on a chip is going to have a unique identity. Our 5G network is going to do an identity verification before it allows it to write its data over that network to our MEC, which is the data center where the data at rest is going to reside for all those algorithms to process that data. So that's been inherently built in and baked in through the use of software-defined networking and secure edge perimeter. And we find that as one of the most critical things because if you recall, we had a problem with server farm proliferation in the military over the last couple of decades. And the way we got around all of the security issues associated with that is we went to the cloud and kind of consolidated the data centers. Now with the advent of all these sensors, we are proliferating the number of edge devices that could potentially be compromised. So for one thing, we lobby to make sure Huawei, the Chinese company, does not get to park any kind of a hardware software in this country because it's proven that both in their hardware and software they have backdoors. And secondly, we have designed a system inherently at the core of the network and the edge of the network, a 5G network, so that it's secure and it does automatic authentication. So it's going to be one of the most critical aspects of the industrial IoT as well as consumer IoT as we look on the horizon.
Hey, Brandon, I got one question. I know you're running out of time. So as we're looking for 5G, going forward to 5G, we have a problem of a lack of infrastructure for the transport within the installation itself. I mean, so they want Wi-Fi and you have copper leading the building. They want Wi-Fi and you have routers that are 70% or 60% of our routers are probably not cyber compliant because they haven't been updated. And then you have non-Ethernet capability within the transport itself. So when you talk about what could we be doing so we're not trying to solve some, today's problems, that we're looking at 5G, and then we make the right investment into our installations to have that correlation between being able to speak to the installation.
No, thank you for that question. It's actually music to my ear. So
I can sing too, but I mean that wouldn't be.
No, that was plenty fine. So in order for us to deliver a gigabit to 10 gigabit per second wirelessly on the RAN side of the network, we need to have fiber optic coming to that radio cell, the small cell. In other words, it's the throughput capacity of the fiber optic that allows us to then use new radio technology to deliver gigabit, 2 gigabit, 10 gigabit per second on the front end. So one of the key things about 5G is that we need high fiber density to the edge where that small cell is going to be located that delivers the radio signal for 5G applications. So anything that would allow us to have access to conduits or any fiber deployment that you could have. And again, it should be in conjunction with a company like Verizon, because you want to deploy the fiber where we think the small cells ought to be located to provide the right kind of coverage for the autonomous mobility, autonomous logistics systems that you're contemplating, as well as future applications that you haven't even thought about, right? Maybe using augmented reality and AR and VR for condition-based maintenance, so the technician can just get instructions live on how to fix, right? So I mean, so those things are all going to need 5G, and in order to do that, we can kind of design the architecture with you, but then the key aspect is bringing fiber as deep as possible into the base.
All right, so I'm going to ask the last question, 1 or 2 sentences from each of us. Today is about unlocking the creativity, right? So each of you, starting with Jay, point out 10 years, what are autonomous vehicles, unmanned systems doing for us? Give us a taste of what you see in use cases.
20 years from now, we're definitely going to be a lot more in the air, and it's something that we've orphaned a little bit today, will be demonstrated, but the work that's going on in electrical systems for aviation vastly reduces maintenance cycles, and it increases the ability for controls, the introduction of ADS-B and other things like that, and so the necessity for us to be able to get those systems online in 20 years is going to unlock a lot of freedoms for us. We think about drones as something that might provide simple things like inner city mobility. The ability to go from the edge to the edge is such an important thing for air mobility. So I'm a huge believer that all of this ends up in the air. The ground is very congested, and the ground has a lot of humans on the ground driving. It's a more controlled space in the air, and I think it's something that we're going to see coming online if 20 years is the horizon we're thinking about.
All right, thanks, Jay. Kevin?
I think VTOL is going to be very dominant because, again, we just don't have the road capacities to deal with the congestions that we have right now. And at some point in time, we're going to find cities essentially blocking the city, except for the residents or people that want to pay maybe 50 to 100 bucks a day just to get into the city, not to park. And that way they can reduce the amount of flow of traffic that comes into it. Washington, D.C., my hometown, gets 500,000 people a day come into work and go out. And when you talk to the mayor, they say, Uber and just shared mobility is not going to solve that problem. It's just too fundamental. So I think at some point in time, you will see shared mobility from perimeter of the cities, bringing people in and out so that you can kind of reduce the congestion. But short of that, and even with that, VTOL is going to be the dominant mode of autonomous logistics and transportation as we look on the horizon.
Ed.
All right, so I'll skip the flying vehicles and go to back to being connected. The main limitation with vehicles operating throughout the United States is the infrastructure that's in the environment, and that can be sensors, but it's also the 5G connection and the low latencies. So I see that on the horizon. I see that as happening. When I did my thesis, it basically boiled down to that. If you want autonomous systems to work harmoniously, they need to be able to communicate and communicate instantly, and that's what I'd like to see. And I'd like to go to work without having to drive, so I can get a few hours of my day back.
Yeah, so we mentioned, Eddie mentioned, I mentioned cost optimized solutions, and as Eddie said, if someone tells you it's cheap today, they're lying. So obviously, when you think about 15, 20 years from now, we've got to address the cost. We've got to get autonomous vehicles mainstream. I think we'll see these cooperative environments of dense urban cities will emerge very fast, and that's where the private vehicles or shared vehicles will emerge very fast with, again, these cost-optimized solutions. I do agree also drones will start showing up, and so it's another population we like to think about, and we did think about it in 5G, where we have a population that's overhead as well as a population on the ground that we have to manage in a very cooperative and collaborative environment. So yeah, we'll see a lot of connected things.
By the way, the only network that has the capacity to handle all of the things that be on ground and all the things that be flying would be a 5G network.
So I do agree that we'll all be traveling like George Jetson 10 or 15 years from now. But from a military perspective, having autonomy in all three of the legacy domains, surface, maritime, ground, and air, is going to change fundamentally the way that we look at sustainment. So gone will be the day of a 60 vehicle convoy that you might have seen in Iraq and Afghanistan. You're going to have a much more distributed environment where you can have a one-off vehicle travel autonomously to deliver a precise payload at a precise time.
All right. Thank you to our panelists. Thanks, guys. Thanks for doing that. All right. Next up is urban air mobility. So we kind of closed on a note about airspace as if it was the next panel. So that was interesting to go there. Before you start that, Nicole, we're going to get our panelists up on the stage. All right, thanks. All right. Okay, so we're going to tease this a little bit. What is urban air mobility? And we're going to use someone that's not on the stage to help us see the future, a little bit about what you heard about at the conclusion of that last panel. So if you can start the video. All right, so what we saw there was the vision of Uber Elevate. Uber in 2016 created, first it started with a white paper where they framed out what the ecosystem of air mobility would look like. These are electric vertical takeoff and landing platforms. And what we've watched them do over the last 3 years now is create an entire ecosystem around this concept. In the back, if you turn off the video, audio, we'll take out that buzz. So we use that to help us see, just like what you heard at the conclusion of that last panel, that where that future is going. And it sounds like Jetsons a bit, if you're old enough to remember Jetsons. But Jetsons didn't have ride-hailing apps. Jetsons didn't have IPOs like what we're seeing now, right? Businesses that are meeting the need right there to the customer. That can actually help shape that entire ecosystem around this future. And so we have this in mind, where your air taxi concept, but we're gonna start more locally and talk about some of the opportunities that have been created here regionally. So we're gonna start with Jesse Guy from San Diego Regional Economic Development Council, and who was integral with the city on starting the FAA's drone integration pilot program here in San Diego.
Thanks, Colonel. I'll talk a little bit about the IPP program and some of I think what we're excited about for urban air mobility as a city, but also what we're doing in kind of the interim steps through the IPP program that's kind of laying some of the foundational groundwork, both from a connectivity standpoint and also from an UTM, unmanned traffic management standpoint, in order to kind of bring this vision to reality. And so IPP is a FAA-run program, integrated pilot program. There were 10 locations selected across the country to participate in this program, and the city of San Diego is one of 3 cities in the entire country selected, the largest city with, frankly, the most complex airspace by far. When you look at the dynamics of our military airspace, dense urban corridor, international border, international airport located in a downtown urban environment, our airspace is extremely complicated. There's 55 heliports and airports in San Diego County. So we have very complex airspace, and if we're able to make large-scale drone operations feasible in a safe environment that doesn't impact these mission-critical military missions that are taking place within our community, it starts to set the groundwork for a vision where you can have larger aircraft flying as well. And so in IPP, we're working with a variety of great partners. You heard from one of them earlier today with Qualcomm, but we've got Qualcomm, Uber Elevate, Matternet, Modal AI, AT&T, Intel, and some other folks, AirMap, GE, Aviation's Aeros, working with us on a variety of different missions. We're working on a food delivery mission with Uber. We're working on a medical delivery mission with Matternet and UCSD Health, where they're looking at doing blood samples directly from the hospital to the lab. The food delivery mission is a partnership between Uber Elevate and Uber Eats. And really the Uber Elevate team is using, and I know Chad can talk a lot about that potentially, but there's a lot going on in those projects that are really laying the groundwork for what the long-term vision is for how are we going to manage airspace in a dense urban environment. And so for Uber Elevate, figuring out how they can deliver food. You think about Uber Eats app. Uber Eats is actually the largest food delivery company in the world by volume. And so they've got a lot of really good data about, one, how long does it take to get food from a particular restaurant to their customer? How long can the food remain good before that customer starts to complain about that food? And what are the traffic impacts of the food in transit between those 2 locations? And so within this project we're working on with them here in San Diego, we're looking at using drones to deliver food directly from restaurants to the end customer and eliminate some of that traffic congestion. In the process of doing that, we're going to have to manage our airspace, and we're going to have to figure out ways to make sure that we're not coming into conflict with the important missions that are happening around the community, and ultimately not only not coming to conflict them, but within reality, do the bases also want to have their food delivered by Uber at some point? We just recently, the bases have opened themselves up to allow Uber and Lyft and these other ride-sharing services to come on base. So we want the things that we're developing with these companies that are going to be services to the broader community to become services to the service members who live on bases throughout the community. And so we've been working with Colonel Newell and the Marine Corps here to do some testing for our project. So there's been some integration between what we're doing both just from an airspace management standpoint to ensure that we're not impacting operations, but also looking at how we bring that technology on base simultaneously, or in some ways even do some of the testing here on this installation and surrounding installations while we're looking at scaling those things within the city. And I can talk more about some of the things we're doing around 5G and other communication stuff, but Chad and Modal AI as one of our partners is certainly more competent on that. So.
Oh, thanks, Jesse. So I recall, I guess it was a year and a half ago, right? We were making some noise about starting up the autonomous vehicle proving ground, and Jesse and Tiffany Vincent, who couldn't join us today from the city, came over, and they were looking for how can we collaborate. They were crafting the proposal to the FAA, which was, and they only selected 10. What was unique about that opportunity was that unlike some of the other Department of Transportation autonomous vehicle proving ground efforts where they never had industry partners, this one was all about having the industry partners and the use cases. So collaboratively, FAA and the location, in this case the city, could drive regulation forward, craft regulation appropriate with the input from the industry that's trying to meet that need, right? Trying to evolve into it. And it created an awesome model of a collaborative market, again, where a federal entity could enable itself by creating a space where that collaboration takes place. And so what's interesting is that even though we saw a vision of this ecosystem of air taxis from Uber Elevate, and their first flights are supposed to happen in 2023 in both Dallas and LA. Well, their focal point, Uber's focal point for that program early on, turned to how are they going to do traffic management? How are they going to shape the regulation that happens of flights over people and everything else? And so since they were selected in this program with the city, their focus came to San Diego and presented an opportunity to San Diego and to ourselves in that relationship. One of the first instances of creating that type of collaborative market involves Andrew Musto here. The first time that I saw that type of thing take place. And so I remember going out a year and a half ago and to a training area in the middle of Central California and watching a company fly prototype air taxis that they had a contract with DIU on. And I was there the same day I watched them fly that the FAA came and gave an experimental license for that company to go back out to where they were from and fly, because of the iteration that they were achieving on the deck in our airspace, our collective DoD airspace, where they had engineers living in tents and just flying in the morning and iterating and then flying in the evening. And so I watched that type of collaborative ecosystem take place and how they pushed the boundaries of what they could do by an asset that we had, both the installation and the airspace. And that was within Andrew's program. And so getting back to this vision of air mobility and tie us to what's happening in the industry and then how we see the applications for Marine Corps installations or operations.
Sure. Thank you, sir. So good afternoon, everybody. Andrew Musto. I'm a program manager in the Defense Innovation Unit. For those of you who are not familiar with our organization, we accelerate the adoption of commercial innovative technologies, specifically very advanced technologies, into the Department of Defense for the purpose of transforming the DoD's capabilities, right? And if you look broadly at research and development spend across the entire nation, commercial entities are outpacing DoD and R&D spending by a factor of about 4 to 1. You can make the argument that those $4 are spent more efficiently than our $1 is in general. So specifically, I'm within the autonomy portfolio, and my specific area of focus is generally UAS. I work at everything from large air taxi programs all the way down to small Group 1 and Group 2, generally in the logistics space with a focus on critical supply delivery and things of that nature. I am actually the guy that helped Jay and his team get the DIU project off the ground, but that's generally outside of what I usually do within the portfolio. As far as what we're seeing with industry in general, I would say that caption that you saw at the end of the Uber Elevate video is very apt. It's very much closer than you think at all levels. We're working to deploy a few smaller systems this summer to a couple non-disclosed locations that will be delivering stuff to Marines at very long distances. And the Uber prediction for when vehicles will be flying is probably not far off the mark.
All right, thanks, Andrew. So I want to turn to Chad Sweet here. So he's going to talk about Moto AI and kind of its origins, but Moto AI, as Jesse mentioned, is part of the IPP program here. And it ties back to what we were talking with Qualcomm and Verizon on the last panel as well, with connectivity. And so how does this future of connectivity start to impact drones that are really radio signals to date, RF signals right now? So where do you want to take us, Chad?
Sure. Thank you very much. So Moto AI spun out of Qualcomm research specifically about a year ago, last summer. We quickly joined up with Jesse and the city crew as a part of the San Diego IPP program. We've been involved in both of the ConOps there, one for border security, the other for food delivery, and helping enable those companies really advance their autonomous programs by connecting them via cellular, connecting their vehicles, their aerial vehicles via cellular back to their networks. We also, quickly after that, joined up with DIU and are working on helping them build a standard or more standardized set of components for the Group 1 class small UAS for ISR operations or short-range reconnaissance operations. And we're involved in two components there. One is an autopilot, which is a computer vision heavy, high computation autopilot system paired with an open ecosystem to help bring best-in-class commercial and off-the-shelf components into the DoD. And the second part of that aspect is a very portable 4G with an evolution to 5G cellular network, and by portable, like ideally sub 1 kilogram handheld portable cellular network that would enable someone in the field to control multiple robotic vehicles and potentially more. And that is where then we got connected with Lieutenant Colonel Newell, who is organizing this AV proving ground. And so this is providing us an outstanding way, providing Moto AI and DIU in tandem, an outstanding way to prototype and characterize these radio systems. And so we're going to be able to go down Rifle Road out there, which is 5 kilometers, long straight 5-kilometer road, which will help us go test the range of our system and really prove out that we can make it happen. And so to kind of highlight some of the topics you've touched on, Brandon, you know, the base may not always work in the supply and demand, traditional economics, but, for new technology deployment, it offers a tremendous opportunity because the two things we struggle with as a commercial entity outside are spectrum and controlled airspace. That's something that you can directly influence, and so provides a great opportunity for us.
All right, thanks, Chad. So I want to come back to Jesse, and I want to touch more on this concept of collaborative market and what you and I have worked on a lot over the last year and a half in many different areas. But it ties back into, what your organization is really about. And so I want you to spend a little more time talking about that and whether it applies to UAS and the airspace or not. It's up to you.
Yeah, so the San Diego Regional Economic Development Corporation is a nonprofit. Most major cities have an entity like us, and what our focus is on is trying to help grow the economy looking at longer-term trends. And so we identify growth sectors within the regional economy, and then we think through, what are the resources that are going to be needed to support those particular industries. And as the aerospace and defense lead for that organization for a period of time, that got me very involved in working with our local installations and thinking about them, not just, there's communities are often dealing with encroachment issues, and it's kind of hopefully in most communities it's not this way, but there tends to be a kind of us and them battle with local communities where you're trying to mitigate issues between the community and not so much think about how you can be mutually beneficial to each other. I think San Diego is unique in that we're not like that with our military installations, that we generally as government entities and as a community lean in and working with the military, but frankly, we saw that there was a much bigger opportunity to use the installations and use the technology that we're seeing from companies within the region to try to create more of a test bed environment between the installations and the companies that we're working with that are doing advanced robotics and doing advanced cellular, a variety of technologies that we know that are having an impact to the military, but we needed a conduit in. And I think, for us, looking at how the city is approaching smart cities technology, right? We're looking at deploying, GE smart lights that are going to do things around, carbon emissions, doing things from traffic patterns, light management, all these things. But all that stops at the fence line, especially in San Diego County with the number of military personnel we have. It's not very effective. We have traffic patterns being created in and out of the bases so that we are not two separate communities. We are a very large region with installations inside of us, and if we cannot have these technologies bleed over the fence line and come back and forth, then we're not going to be as effective as we could be. And so through really just kind of reaching out to people at different installations and trying to figure out who was open to engaging in those types of conversations, I think that's how we got connected to Lieutenant Colonel Newell, at that point, Major Newell, and figuring out how can we find a way to bring companies like Modal AI who have solutions that are both going to impact the community and have a real business growth opportunity for our region, but also have insights for the military, even if it's just from watching where the technology is moving for kind of a scouting purpose, but beyond that, looking at how do you shape the requirements for this technology that's being developed by companies who are looking for first customers, who are trying to develop their MVP, and who need those test environments. And so I think that's where the partnership around IPP and what we've been doing with Lieutenant Colonel Newell here at Miramar has been particularly unique and a special added advantage for us in this region, is that we have great companies who are, one, often willing to work with the military in a variety of different ways, both directly and indirectly, but then are also, we've found commanders at the installation level and folks like Lieutenant Colonel Newell who've been able to find individual commanders who want us to showcase the technology and work on the problem set with them. And I think that's something that we're going to continue to cultivate, whether it's in unmanned aerial vehicles or in other problem sets that our organization works on.
And so I want to come back to something we talked about in the last panel, which is earning our seat at the table for this emerging technology. It's not enough to just have, collaborative dialogue, right? It's just like what we did with Qualcomm and the autonomous vehicle, just like what we're doing with Verizon for the 5G. Earning our seat at the table to better understand where that market is going, where it's driving, and what are the applications. And that goes beyond just, some of these platforms. It's really not about the platforms. It's how are we going to manage our air traffic? How are we going to have UAS air traffic management? How does it blend into kind of the archaic system with which we, optimize or manage our airspace here today around this facility? And certainly, how does it go forward into operations on the battlefield for us? We cannot solve that in a vacuum inside DoD. We'll put a lot of money to it, and we'll solve it very ineffectively. But through the collaborative opportunities that we can leverage through these types of relationships is critical to it. And so, we're actually with Andrew doing a counter UAS effort, right, that was developed within his program. And we took the opposite turn, where we were focused on the battlefield with that capability, we, the collective Marine Corps, and then we looked at facilities applications, right, so that we could better understand in a more congested environment how it applies. And so we don't have to get into any specifics, but just talking about how we leverage all these insights, all these opportunities to not only look at the use case, but also our mitigation of the threat that comes with the use cases. You have any thoughts on that, Andrew?
Absolutely. So a lot to unpack there, right? Starting with how we get our seat at the table, industry in particular is very transactionally driven. They are by their nature. That's how the entire country is set up to operate, right? If you look at the history of Defense Innovation Unit, formerly I-werx, experimental, they initially just dropped a bunch of folks from the DoD out in Silicon Valley and in Boston and said, go make friends, effectively. Like, that was the mission. And they had meetings, and then they had more meetings, and they had more meetings, and eventually people were sick of talking to them. So one of the things that we as DoD need to understand is that you have to have an end state in mind. You have to come to the table willing to play and willing to actually put money into these ideas, or people are just not going to be interested in talking to you. Not that they don't want to, but They just have other things to do with their time, frankly. As far as pulling commercial technology into the DoD and using it to solve problems like counter UAS, which is actually not separate and distinct from this problem set in general, right? It's a subset of airspace control that we don't have solved, frankly. There are things that are starting to solve it, but it's a very, very nasty problem set when you start talking about universal traffic management and non-cooperative actors that may be operating within that very congested airspace that we expect to see here in the near future. And the commercial actors are working a lot harder on solving that problem than we are, frankly. We got a lot of really great OV1s, but at the end of the day, the folks that are going to solve it are the ones that are going to be making thousands and thousands of deliveries a day in a congested airspace.
And so I want to highlight that through the relationships that have fostered here, we've actually taken the next step with Uber Elevate, where we've joined Army Research Lab in a CRADA, collaborative research agreement that they have with Uber Elevate. That kind of facilitates that dialogue to a greater extent. And similar to how we focused on the relationship with Qualcomm, the market maker, if you will, not necessarily the vendor. That's what we were watching, and Jesse and I were there last year at the Uber Elevate Summit. We're watching this whole ecosystem emerge, right? So in that video, you saw that you would have had to not only tie back to the customer and get them to the skyport, but what's the design of the skyport? You saw the traffic management having to take place with multiple vertical takeoff and landing platforms coming in and out. How many people are supposed to be able to sit in that platform? You saw the U.S. traffic management, as I mentioned, and then the vendors themselves that are designing the platform. What's unique in that relationship, and I can't think of another parallel, is that Uber Elevate is not designing the platforms. They're designing the specific standards by which those that are designing the platforms can then basically be authorized to fly in their network, right? And so the ability to get that type of insight through these relationships and better position ourselves into the future, I don't know that anyone else would have included urban air mobility in this type of event, frankly, because it looks too far out. It looks too much like it's Jetson. And it's only through the types of relationships that this body's been able to foster that helps us see what that looks like in the future. So as the group that's with us over the next 2 days looks at 2035, we actually can value, what that airspace looks like for us and what it's doing for the movement of people and goods. And so, Chad, just thoughts on the applications for what you're doing with Moto AI in the commercial market and where are you looking to impact and shape?
Oh yeah, well that's a great topic. It's broad though, but yeah, obviously what we see a lot of, what's represented up here. But whether it's package delivery, there's certainly opportunities to ease congestion and augment the existing infrastructure by replacing that with aerial. Because cities like San Diego are not. Well, they're not laid out in a grid, and it's not that uniform and regular. And so there's lots of hills and mountains and things that can be traversed with air much more efficiently than on the ground. And then obviously there's a lot of discussion in drone delivery for medical applications very, very recently. And there's Matternet, right? Yeah, but on the other coast. Yeah. What's that? Oh, okay, good. And so with, reasonably lightweight but high value cargo, that's pretty critical to aerial and unmanned, especially in the smaller use case. And then trying to bring as much of that technology as we can and leverage as much of that effort as we possibly can back with our relationship through DIU to bring best-in-class components into the DoD and the Group 1 applications they're going after.
All right.
I can speak to that a little more. So about a year and a half ago at Defense Innovation Unit, we started taking a look at the small UAS market. A number of DoD stakeholders came to us saying, effectively, there are no good solutions out there. It's very difficult to acquire a good small UAS that doesn't come direct from China. And those that do they have their own security issues that we're not okay with, et cetera, and so on and so forth. And we looked at the market, and it was true. Not only could you not buy a good small UAS, you also couldn't buy the components to assemble a good small UAS. There were tons of folks that were doing effectively hacked together minimally viable products in the S&T shops, where they were building, quadcopters that were working, and they were proving that this thing could do the thing effectively, but it wasn't a truly well-polished end product, right? And the folks that were in the space of building small quadcopters and small robots and things like that were not the folks that were in the space of building very well-defined and well-documented and well-performing integrated circuits that could do edge compute and things of that nature. So when we were looking at, okay, how do you develop a small UAS and even a small robotics reference architecture for the future so that folks in industry can take a look at, all right, what do I buy for my compute board and my communication stack, and what software do I put on it? Model AI was very exciting to us because it's a very good solution for a fairly low price that you couldn't necessarily get otherwise. If you see one of these vehicles that are coming out of China right now, one manufacturer in particular, they're effectively flying cell phones. And that's a very, very hard thing to build. And in the majority of the US market, we've kind of lost the ability to build that to an extent at the lower levels. And we're trying to get that back, and we're hoping to see more and more things like that come into the hands of folks that are building things for DoD.
All right, great. So we've got about 10 minutes for questions. So Jess, if you want to take one of these mics. Do we have any questions?
So very exciting. Just your experience with the FAA. I mean, how are they doing? Because, it's a lot of opportunity until you regulate it. So, the ground domain, air domain. The video shows people coming in and out all over the place until it gets regulated. So, and that comes out of fear. So, the regulatory commission that controls and can provide safe access is either going to handle it or they're going to lock it down. So, can you share some thoughts on that, please?
Sure, it's a good question. Well, one of the things right now it is locked down, right? So from the UAS marketplace, we are adding. We started from a position of you can't do anything, and now we're working our way towards you can do certain things in certain airspaces with limited exposure. You have to get waivers every single time, every single airspace, every single mission, and so we're continually kind of building with the FAA. What are the risk mitigations that need to be built in from an operational standpoint, from a communication standpoint, from a command, cyber, all of those things in order to start saying, okay, Uber, you have permission to deliver food in San Diego, LA, San Francisco, Boston, Chicago, wherever you want to do it, go. And we don't need to come check in on you every time you want to go fly. Right now, we're not there. Part of what IPP was doing that was different than some of these other UAS test environment cases, those were set up in Alaska, in the deserts in Nevada. Those were more about airspace worthiness, testing the core technology of the aircraft, but not how do you actually do this where the customer is. Amazon, Uber, all these guys, they don't want to go fly in the desert in Nevada. No one's getting Prime delivered in Fargo at a regular rate. Like they want to do that here. They want to do that in major cities. And so that's the difference what IPP is trying to push the envelope on. So to answer your question, the FAA is making progress, and I think the industry is certainly very eager to demonstrate that the technology has come a long way. We've had many meetings with our telecommunications partners in IPP, sitting down with some of the chief technology officers within the FAA's Unmanned Systems Integration Group, showing them data that they've collected from real-time flight operations on 4G networks, showing the reliability of the C2 link on current cellular networks, let alone what's capable for future 5G networks, and they don't know that. They didn't have that information. So there's an education component of demonstrating the level of safety and reliability of the technology that IPP is trying to enable for the FAA. I mean, they are, safety first. That is their mindset, understandably, so it's a whole evolution for that organization to think about: does 10 to the -9 as a safety standard make sense for every type of UAS operation in every single environment, or should we change how much risk we're willing to accept? How much do we evaluate what the mission is? You know, if you're saving a life, if we can guarantee that we're going to go save a life because I'm delivering valuable blood to a hospital, and do we still care that it's 10 to the minus 7 instead of 10 to the minus 9, that drone might come down? So those are the kind of questions the FAA is grappling with. It's very challenging, but I think that they've really been open to working with industry to help solve this problem for them, because it's not going to be managed on, you know, FAA is not going to have ground control, air traffic towers in the same way. It's going to have to be automated. It's going to have to be a network. It's going to have to be a federated system, and there's going to have to be a lot more technology providers involved in that solution than maybe what they're used to when there's a few kind of controlled primes that they can manage the manufacturing process and they can kind of work through. This is a different ecosystem. And the last thing I'll say is, when you look at the number of registered drones, like through Drone Zone, it's like 2.5 million registered drones. Those are hobbyists, commercial, everybody. The FAA is, right now in terms of certified aircraft, has got about like 350,000 certified aircraft. Not all those are flying. Those are your Cessnas that are parked that haven't been flown in 30 years. It's everything. So the scale of this industry, and it's not even really live yet, is completely different than what the FAA is used to, but I think they're working very aggressively to lean on industry to help them figure out the right solution.
So I would just pile onto that, and first I would agree that the FAA actually has been very forward-leaning from what I've seen, although technology is outpacing policy in this case. And I think as the curve of technology acceleration just gets more and more vertical, we're going to see that in more and more sectors. And in many cases, in many instances, it's a case of want versus need. The FAA doesn't have to allow you to get a burrito delivered to your doorstep via quadcopter right now. In fact, we as a nation have basically mandated that they be very, very restrictive, which is a good thing, but we see them stepping forward, and we do see that changing. Interestingly enough, the largest autonomous delivery system in the world, one of the most advanced systems that you can find is in Rwanda. And it's a company called Zipline who's doing almost all of the delivery of blood and plasma in the entire country is happening by drone. It comes from the capital and it goes out, and 30 minutes later, a couple units of blood show up at an outlying small hospital and go to a mother who's delivering a baby. Incredibly impressive system, more reliable than many of our aviation assets in the United States, but we just don't have the policy to enable the instantiation of something like that here. I would argue that we, as a service, have a different mandate than the FAA, and we're probably a good organization for many of these folks to partner with, because we are a little bit more risk tolerant. I wouldn't say we're very risk tolerant. Now, I would argue that we should try to be more risk tolerant in some cases, but we're certainly more risk tolerant than the FAA, especially when it comes to pushing the boundary of filling out what the continuously evolving character of war is.
I got a question. It's more than just the FAA dealing with this stuff. The FCC has got designated channels for ground-to-ground, air-to-ground, and air-to-air communications. Is there any discussion about building out a dedicated drone level of activities in the cellular frequencies versus, you know, on the helicopter type stuff that's already private channels?
Yeah, we can speak a little bit of that. We're under a contract right now through DIU to build a prototype cellular-based system for small UAS. And it would be, you know, ideally within 3 to 5 kilometer range communication. So single controller, single pilot, multiple vehicles would be the big advantage. The other advantage would be you could take really any device right out of your pocket and connect to the system and also be communicating with any of the vehicles deployed. Actually, no, this would be a portable cellular network in DoD spectrums, the 1800 megahertz band specifically.
Roger that. So currently the cellular companies can only go so high in their elevation of transmitting and receiving signals in a designated allocation for ground-to-ground. What you're saying is using military spectrum with the authorization, not so much as the 5G millimeter wave, to being able to get through different types of climate activities to ensure the reliability of communications with the cellular function is higher reliability.
Yes.
question here in the back.
Great presentations. I really appreciate the information. My question is getting back to the point somebody made about China and some of the manufacturing advantages that they have. How much of a disadvantage, or what are your thoughts on the challenges that we face in the United States with the regulation that we have with respect to data and manufacturing practices and other things in the competition with China in developing technology?
Was the new director of World Trade Center in San Diego. I think this is right up your alley.
Well, it's probably better for Chad because their business model is being, kind of addressing this problem. But yeah, I think that there are, when you look at the companies that are involved in our program, either American or European country, and we have a Matternet, which is a Swiss-based company owned by Mercedes-Benz, but our public safety ConOp, which involves Chula Vista Police Department using drones to respond to 911 calls and provide live camera feed back to the responding officers to provide better operational intelligence to them, they're flying DJI. And it's because it's the cheapest, most reliable aircraft that they can find. So there's a lot of law enforcement right now and a lot of other public safety entities that are flying equipment that DoD has broadly banned. And they know that. They're just still choosing that the risk, and they have, this is being used. They've had 14 arrests directly related to the drone operations that have been live as part of IPP so far, and it's assisted in other cases. So they have all kinds of, very strict evidentiary standards on what's happening with that data as it comes off, where it's going into their cloud storage. And we've mentioned to them, is this a concern about potentially any backdoor issues with the DJI that have been expressed by DoD? And it's kind of like, sort of, but it seems like it's too far away for them to deal with. And I think that a lot of those agencies would pivot quickly to an American product that was American made, or an allied nation product if they knew it was at a competitive price point. Because they were still in the process of demonstrating the added value. I'll tell you right now, Chula Vista PD early on was trying to scrap together resources from their foundation to make this project happen. Now they're at the point where they're saying, do we really need to buy 2 new SWAT cars? We could buy 30 drones because the add value is exponentially better for what we're getting. But until you have these live real-world demonstrations taking place where you can really see the impact, it's harder for agencies to figure out where they're going to spend their funds.
So we are working on a number of programs that are not just advancing components like the one that we're running with Chad, but also actually building full-up small drones to address this problem. And yeah, when the police went to buy their drones, they likely found that it wasn't only the cheapest drone, but it was also probably the best drone that they could find, and not by a small margin. Both anecdotally and empirically, they're just very, very good, which is not great news for the U.S. industrial base, but we are working on it.
And I think one of the questions, what are some of the manufacturing challenges? I'd say versus China, I'd say, the cost is cost, and that's understood. I think for the customers that care about U.S. built, the cost isn't prohibitive. I think it's fine. It's actually, on our side, what we see is just establishing that supply chain where certain components in Shenzhen literally just fall out of the sky or out of a window of a building, as they go around with a net. It's unbelievable. And for us, we have to struggle. We're up in the middle of the night, yelling at people on the phone. It's impossible to get certain components. So I'd say that would be where some of the challenges come in, just that ecosystem, which hopefully, the World Trade Center efforts help advance. But it's the ecosystem in the U.S., whether it's, degenerated over time or however you want to think about it. But in China, there's things like supply of components that are just much, 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 much easier.
One last question. I just highlight that, kind of tying in this last, responses to the question is that we have other roles to play as the military and the Marine Corps. And sometimes the signal that we set whenever we see the gaps in the industry base and the vulnerabilities that it presents to us, we can play that role. And we've done it in the past. We, the Marine Corps, are too small and under-resourced to be the leader in playing that role, right? Creating that whole signal that's going to unlock industry and the opportunity for industry. But what we can do is events like this where it really highlights why it's critical, why it's not just critical to our use cases and our applications and the mobility, moving people and goods around bases, but also the second and third order effects to the nation. It's critical as well. And so we can't do that without these guys joining us here and without you being here, you know, talking about this with us. And so we're going to break here. We're going to go back out to the exhibit area for about an hour, and then we'll have a panel for electric vehicles, and then we'll have some closing remarks. And so again, appreciate you all being here, and thank our panelists, please.